Okay, so today we're going to be doing topic 7.4, and that's on nonlinear functions. And the objective is the same as it was yesterday. I can classify functions as linear or nonlinear. So my learner's question is going to be the same, is what is the difference between linear and nonlinear functions. Okay, so as a recap, a linear function is a function whose rate of change is constant. Okay, so if a linear function has a rate of change that's constant, that means the graph is a straight line. Okay, so if a linear function has a rate of change that's constant, okay, that means a nonlinear function has a rate of change has a rate of change that's not constant. Okay, so a function whose rate of change is not constant. Okay, and if the graph of a linear function is a straight line, that means the graph of a nonlinear function is not a straight line. Okay? The graph is not a straight line. I can spell right. Okay, so not straight line, not constant rate of change. Okay, so if we're looking at this first table, okay, I see that my inputs are always the same. So if I want it to be linear, my outputs also have to be the same. So on my first one, my output's 2, and on my second change, my output's 1. Okay, now remember, the rate of change is the change in the output divided by change in input. Okay, or we could say change in y over change in x, vertical change divided by horizontal change, so on and so forth. Okay, so if I want to check to see if these rates of change are equal, I'm going to divide the change in my output by the change in my input, which would be 2 over 1 for the first one. Well, 2 divided by 1 is 2. And for the second one, it would be 1 divided by 1, which is just 1. So 2 and 1 are not equal. Therefore, my rates of change aren't equal. I'm sorry, I didn't realize you couldn't see that. There you go. So my rates of change aren't equal. Okay, so this is nonlinear because rates of change aren't constant or equal. They're not the same. Okay. Okay, so if we're looking at this graph, I could try to figure out the rates of change between each of those points and so on and so forth. However, I'm looking at this, and the definition of a linear function has straight line in it, and so this isn't a straight line, so this is nonlinear because graph is not a straight line. Okay, so I can just by looking at this, I can tell. Okay. So on example number 1, it just says label each graph as linear or nonlinear. Okay, so this first one, I'm looking for a straight line in order for it to be linear. So this is not a straight line, so this is nonlinear. Okay. So because not a straight line. Okay. Then I go on to the second one. Does that look like a straight line? Yep, looks pretty straight to me, so that one's linear. Okay. And then the last one, this is a little bit different because do I have straight lines? Yes, but I need one continuous straight line. Okay, so this is nonlinear. It's a straight line, one straight line is for linear. Okay, so this one is nonlinear because it's not one, that is important, one straight line. It's two that are connected together, and that's not what we want. Okay? Okay, go ahead and do the U-try where you label each graph as either linear or nonlinear. Okay, so now we're going to move on to example number 2, and it says determine if the tables represent linear or nonlinear functions. Show or explain how you know. Okay, so in order for them to be linear, okay, my rate of change has to be constant. Good. I'm assuming you answered that. Okay, whereas nonlinear functions, my rate of change is not constant. Okay. Okay, so it wants me to show or explain how I know. So I'm going to have to show if the rate of change is constant or not constant. Okay, so remember it's change in y over change in x, or change in output divided by the change in input. Okay, so on this one, if I check, my change in input is always +1. Okay, I'm not going to write that 17 times. Okay, now my change in my output, if I do -8 minus 8, that gives me -16. So this is -8. Okay, if I do -16 minus 8, that gives me -24. -24 minus 8 gives me -32. And -32 minus 8 gives me -40. So because my output is constant and my input is constant, that means my rate of change is always going to be -8 over 1, or just -8 if you just want to write that. So this is constant, which means it's linear. Okay, so because my rate of change is constant, it's linear. Okay, okay, letter B. Check my inputs. Looks like they're always 1, so +1 all the way down. Okay, then I'm going to check my outputs because I want them to all be the same, the change to always be the same. 1.5 to 2.5 is just +1. 2.5 to 5.5 is +3. Okay, so already right there, okay, if I do 1 divided by 1 for the change from here to here, that's 1. But then 3 divided by 1 is not equal to 1. So this, therefore, this is nonlinear because ROC not constant. ROC, remember, is rate of change, not constant. Okay? I'm going to make some room on my C too. Okay? So now I got to check the last one. So 1 to 2, 2 to 3, 3 to 4, 4 to 5, always 1, the same. Okay, so therefore if I want it to be linear, the output change has to be the same. Okay, so 1 to 3 is a change of 2. 3 to 6 is a change of 3, and already right there I've got a problem. Okay, so that's a problem. So this would be 2 over 1, and this one would be 3 over 1, and that's not equal. So nonlinear because rates of change not constant. Okay. Okay, go ahead and do the U-try number 2. You're again just determining if this represents a linear or nonlinear function, and you're saying how you know. Okay, now we're going to move on to our last example, example number 3. Suppose there are 20 rabbits on an island and that the rabbit population can triple every 6 months. Make a table of values to show how many rabbits there would be after 2 years. Determine if it represents a nonlinear function and explain, and then figure out how long it would take to reach 1 million rabbits. That's a lot of rabbits. Okay, so the first thing we're going to do, I'm going to do A, and I'm going to make a table of values to show how many rabbits there would be after 2 years. Okay, so they want me to figure it out after 2 years. Well, 6 months, okay, that's not in years. So how much of a year is 6 months? It's half a year. Okay, so I'm going to put years as my label for my table. Okay, and then number of rabbits as my other title. Okay. So at year 0, at the very start, there were 20 rabbits. Okay, then after the first half year, okay, it tripled. Well, what does triple mean? Okay, it means to multiply by 3. So I'm going to start multiplying the previous year's population by 3. So 20 times 3 is 60. Okay, so that's after half a year, my population is now 60. Okay, after a full year, I'm now taking the previous year's population and the previous half year's population and multiplying it by 3. So 60 times 3 is 180. Okay, now I'm doing after a year and a half, again, 180 multiplied by 3 is 540. So after a year and a half, there's 540 rabbits. And then after 2 years, it's 540 times 3, which would be 1,620. So there would be 1,620 rabbits after 2 years. So I'm just writing that as the answer to that question. Okay, so then B, does this relationship represent a nonlinear function? So what do I have to check? I have to check my rates of change. So over here, we're used to the change being 1. Well, as long as it's constant, okay, it's fine. Okay, so this is 1/2, so it's always going to be the same for the input. Okay, now I got to check my outputs. From 20 to 60, that's a change of 40. And from 60 to 180, that's a change of 120. So that's already right there, not constant. Okay, so this is a nonlinear function. So actually, the question says, does this relationship represent a nonlinear function? The answer is yes, because the rate of change is not constant. Okay, so then I'm on C. So now I need to figure out how long it would take to reach 1 million rabbits, okay? So I left off at after 2 years, so I'm going to go ahead and go to 2.5 years. Okay, so that would be 1620 times 3, which gives me, if I use my calculator, 1620 times 3 gives me 4,860. Okay, third year, okay, I do 4,860 times 3, and that gives me 14,580. Okay, after 3.5 years, 14,000, I could just multiply by 3. 14,580 times 3 gives me 43,740. You don't have to put the commas if you don't want to, that's fine. After 4 years, I do 43,740 times 3. And that gives me 131,220. We're getting closer. After 4.5 years, 131,220 times 3 gives me 393,660. Whew, I think we're almost there. Okay, 5 would be 393,660 times 3. And there we go. We got pushed over a million. 1,180,980 rabbits. So after 5 years. Okay. Okay, so after 5 years, there would be more than 1 million rabbits. Okay. Okay, go ahead and do the U try. It talks about Missouri. Yay digits talking about Missouri.